In this video, we're going to be discussing linear inequalities in two variables. Now, when you graph a line, it's very simple. You can either graph by intercepts, you can graph using slope-intercept form, whatever it is you wish. But the minute you change that equal sign to an inequality sign, everything changes. That line becomes the border, and then the inequality means that we're going to have a whole group of points that satisfy that inequality. So your solutions for an inequality are always going to be some kind of two-dimensional drawing with shading so that you have the whole area that will be your solution. So when you are graphing, you can replace that inequality with an equal sign and then do your business, right? Draw a solid line if the original inequality contains an equal sign. Make sure that it's a dashed line if it does not. If it is strictly a less than or a greater than, then you will have a dashed line. And then I usually tell people to choose a test point because it's going to be either above that line or below that line, to the left or the right, whatever the case may be. But use a test point. I try to use 0, 0 if I can because it's easy to plug in. If that test point works, that means that half plane that you are in right now, that you are testing that point in, that entire section will be highlighted or shaded because that entire section will satisfy the inequality. If it's not, if it's false, then you shade the half plane opposite of where you are. All right, so let's do some examples. All right, so the first thing I can do is just write this equation as an equality. Notice it does have an equal sign, so that equal sign right there means that we will have a solid line anyway. So this is going to be a solid line. 4x minus 2y equals 8. So I am a big fan of graphing with intercepts. So I am going to graph it that way. If you want to change this into slope-intercept form and then graph, that's fine. That's up to you. But I'm a bigger fan of intercepts. All right, so if I plug in 0, I get negative 2y equals 8, which means y would have to be negative 4. And if I plug in 0 for y, I get 4x equals 8, which means x will equal 2. So 1, 2, 3, 4. There's my y equals negative 4. Here's my x equals positive 2. And then I would draw my solid line. Now again, if that line, if that inequality didn't have that equal sign underneath it, then you would make that a dotted line. And then I'm going to choose my test point right here. I like 0, 0. It's an easy point to test. So I usually encourage students to use 0, 0. Now, if the line is on 0, 0, obviously you can't use 0, 0 as your test point. So you'd have to choose some other point. So I plug that in and I get 0 minus 0 is greater than or equal to 8. Is 0 greater than or equal to 8? It is not. So that means that this entire half plane where the x's will not be shaded, and we will shade the other side. So I'm going to highlight the other half plane here. So that means any point within this region will satisfy the inequality. So there is your answer. All right, in our next example, notice that we have a strictly less than sign. So when we graph this, our line should be dotted. But for simplicity's sake, I'm going to put the equal sign in. Again, I'm going to use my intercepts because it's in standard form, and that's what standard form was made for. So if I plug in 0 for y, I get 3x equals 12, which means x has to be 4. And if I plug in 0 for x, I get negative 4y equals 12, which means y equals negative 3. So I'm going to graph those 2 points, 1, 2, 3, 4. There's x equals 4, and y equals negative 3 is right there. So there are my intercepts, and I'm going to draw my dotted line through those 2. And then again, I'm going to do my test point to see which half plane I'm shading. So I'm going to test my point 0, 0 again. I'm a big fan. So I get 0 minus 0 is less than 12. Is 0 less than 12? It is. So that means that we shade where that point is, the half plane that that point is in. So everything above this line where that test point was will get shaded in. Anything in that region will be a solution to that original inequality. Now, if you have some very simple inequalities like x is greater than a or y is greater than b, those are going to be your special vertical and horizontal lines. So when you shade there, it's either greater than, like if you're doing x's, x is greater than will be this area to the right on the number line, because these are all the numbers that are greater than whatever that x is, and then x is less than will be everything to the left. When you're doing horizontal lines, greater than will be everything above, and less than will be everything below. So these don't require hardly any work at all. They just require that you're paying attention to the signs. So if you look at y is greater than 1, that is the line y equals 1. It's a horizontal line. Notice it's going to be dotted though, right? Because we have that strictly greater than sign. So I'm going to put in the line y equals 1, but I'm going to make it dotted. And then notice it says y's are greater than, so that means I'm shading everything above. So my solution is everything not on that line because it's dotted, it's not included, but everything above it will be. So there would be the solution right there. In the next example, x is less than or equal to -2. X is a vertical line, and that inequality means it's going to be solid. So I'm going to draw a vertical line at y equals -2, which is right here. And then I want x is less than -2, which means I'm going to shade to the left. So notice I really didn't even have any math to show. I just had to use my prior knowledge about vertical and horizontal lines to do that. All right, now you may be given something that's non-linear. So please note, not everything will be linear in here. Here we have x squared plus y squared is greater than or equal to 16. Again, we've got the inequality, so it's going to be solid, whatever it is. X squared plus y squared equals radius squared is the equation of a circle whose center is at 0, 0. So we have x squared plus y squared equals 4 squared, right? 16 is 4 squared. So if we start at the center and we go out 4 dots in either direction, 4 tick marks, there's our radius. This is going to be solid, so I'm going to draw in my circle. Please don't judge my drawing because I have a very hard time. Circles are very hard to draw. Anyway, it's a little off, but you get what I'm trying to go for. All right, and then I'm going to do my test point. Again, 0, 0 is not on this graph, so I'm going to test that. So I'm either going to shade inside the circle or I'm going to shade outside the circle. So let's test our point. So 0 squared plus 0 squared, is that greater than or equal to 16? It is definitely not. So because it is not, that means we are going to shade everything outside the circle. So everything out here will be shaded in, and any point in this shaded area will be a solution to that inequality. All right, the next one we have x squared plus y squared is less than 25. Again, that will be dotted because there is no equal sign there. And if you remember from the last example, this is just also a circle. This is x squared plus y squared equals 5 squared. So this time our radius is 5. So from the center, I'm going to go out 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And then draw the dotted circle. Okay, this is going to be even worse because I can barely draw a circle. Now you want me to do it dotted, so I'm just going to do my best here. Okay, there we go. That's the best I can do. Right, and then again, you're going to do your, let me do that in green. You're going to do your test point because we're either going to shade inside this circle or outside this circle. So let's test 0, 0. We're going to test right here. So 0 squared plus 0 squared is less than 25. Is 0 less than 25? It is. So that means every point inside this circle will be shaded. So any point in this region will get you a solution to that inequality. All right, now we have some applications where we can also use these inequalities, and here's one right here. Here's a system of inequalities, which we have two inequalities. We have our first inequality, we have our second. So X represents the age of the child and Y represents the heart rate. If you are reading these, I am a big fan of highlighting stuff. So I'm going to highlight what X represents, and I'm going to change my color so that I can say Y represents the awake heart rate. All right, so it says show that the point B, which is 6, 9, so 90. So again, there's your X, there's your Y, is a solution to the system of inequalities that describes a normal awake heartbeat. So all I have to do is plug these in and make sure they work. And that's it. So let's plug in xy into the first equation. So 6 plus 90, is that greater than or equal to 70? So 6 plus 90 is 96, and 96 is definitely greater than 70, so that checks out, so that's good. Now let's check the second one. 2.6 times your x, which is 6, plus your y, which is 90, is that less than or equal to 115? So 2.6 times 6 is 15.6, and 15.6 plus 90 is 105.6, which is less than or equal to 115, so that checks out as well. So the point B, which is 690, satisfies both. It is a solution. So I'm just going to write is a solution instead. Is a solution because it satisfies both of those inequalities. So sometimes you don't even need the graph of your inequality to use an application of these things. So just keep that in mind. Next time, come back and we'll do some even more. We'll graph some of these systems of inequalities.